So here's another video for Algebra Chapter 6. We're going to be dealing with 6.3. We're still solving linear systems, but this time we're going to show you another technique. This is adding or subtracting the equations to themselves. All right, so let's take a look at what I mean by that. So here's number 1 right here. We have two systems of equations. We have x plus 2y equals 13 and negative x plus y equals 5. Keep in mind that our goal in these videos are to find this coordinate point that they both have in common. So I need to find first a value for x, and then I need to find a value for y. Or I can find a value for y and then x. It doesn't matter. So here I have two equations, and one of the things that I see right off the bat is that the value for x, here I have a positive x, and then in my second equation I have the value for x as negative x. So if I actually add these two equations together, this x is going to cancel out. So let me show you what I mean here. So let's add these together. So positive x plus negative x is 0. 2y plus y is 3y equals 18. So here I have now I only have one variable that I'm worrying about. So I can just continue on and get rid of that 3. And that leaves my x by itself, leaving me with y equals 6. So I've just found my first variable y, so that equals 6. So now what I can do, now that I know what y is, I can just plug it into any one of these equations to find my x value. So let's plug it into this one. It seems like it could be a little easier. Negative x plus 6 equals 5. Okay, so I want to get rid of my 6. Leaving me with the new equation of negative x equals negative 1. And of course I have a negative sign here, so let's multiply by another negative to get it positive. So that leaves me with x equals positive 1. So there it is. There's my coordinate point. It's 1, 6. So if I were to graph this out, I would find that these lines intersect at 1 and 6. So let's check these. Let's see what would happen if I were to plug them in. So let's see here. My x is 1, so that's negative 1 plus 6. Negative 1 plus 6 is 5. So yes, that checks out. Now let's check the top one. So again, that's x is negative 1, 6, y is 6. 2 times 6 is 12. And actually x is positive 1, not negative 1. Sorry. X is 1 plus 12, that's 13. So yes, this checks out as well. Okay. All right. So now that we see that this equals it, let's move on to the next problem. So I'm looking at number 12 now. I have two equations. Now I'm going to approach this one a little bit different because I have a y here, but they're both positive, so they won't cancel out. So what I'm going to do is I'm going to subtract my bottom equation from my top. Okay, I want this to be negative so it can cancel out my y's. So what I'm going to do is I'm going to multiply this entire equation by negative 1. By doing that, this equation, it does not change. It still remains the same. The only difference is that I'm changing the signs to all of these. Okay, so I can do this as long as I multiply the negative 1 to each term in this equation, then it's okay to do that. Okay, so my 5x turns into a negative 5x, my y into a negative y, negative 10 now is a positive 10. So here's my new equation, so I'm going to ignore this one now. Okay, so that's 6x minus 5x leaves me with just x plus y plus negative y is 0, and then 10 minus 10 is 0, so x equals 0. So now what I can do is I can plug this into any one of these equations. See, 6 times 0, because that's what x value is, plus y equals negative 10. So basically my y equals a negative 10. So I have now my value, my coordinate point, which is 0, negative 10. And I can go ahead and plug this in and check each equation. X is 0, so x 0 times 6 is 0. Y is negative 10. Negative 10 equals negative 10. Yes, let me do that with a different color. In fact, let me clean up some of this. Okay, good. We cleaned up some of our mess there. Okay, so this is 0. So 5 times 0 is 0, and y is negative 10. Does negative 10 equal negative 10? Yes, so both of these check out. This coordinate point is the solution for both of these equations. All right, let's move on to the next problem. Okay, so here we have number 19. Now with number 19, I noticed that these equations are not quite balanced in the sense that on the left side I have my x and my y term, and over here on the bottom equation I only have my x term on the left. So I want to move my y term over. And you can do that. You can rearrange these equations as you wish as long as you do it mathematically correct. And what I mean by that, if I want to move my y over to the left, I need to subtract 5y. So that leaves me with a brand new equation of x minus 5y, right? Because whatever I do to this side, I must do to this side as well. And x cannot subtract from y because these are not like terms, so I can just, put them together like this. Equals, and I'm left over here with negative 38. So there's my new equation. All right, so here's my, here's this one right here. Negative x minus y equals 14. Okay, so let's work this out. So negative x plus x is going to cancel out, and then negative y minus 5y will give me negative 6y, so I can ignore that 0. And negative 14 plus 14 is negative 24. All right, so I'm getting closer now. So I want to get rid of that negative 6y. It's attached by multiplication, so I divide, and I'm left with y equals 4. All right, so I found my y. Now I can plug my y in. I'll plug it into this top one. Okay, so I have negative x minus 4 equals 14. Okay, so I want to add my 4 to get rid of it on one side. That leaves me with a brand new equation of 18. I want to get rid of that minus sign. So minus times a minus is a positive. That leaves me positive x with negative 18. And this is the answer to this particular systems of equations right there for number 19. Okay, negative 18 and 4. So let's work one more out. Number 31, this is 5/4 plus 2/5 y equals 14, and 2/5 y plus 1/5 x equals 11. They're pretty balanced out in the sense that I have my x and my y's all on my left side. Keep in mind, it doesn't matter. It can be on your left, it can be on your right. It doesn't really matter. The important thing is that they're all on the same side because it's going to make it easier for me to be able to eliminate one of the variables. Here I have my variable y. Both of these variables have an attached 2/5. So I'm going to get rid of one of these two. And like the previous problem, I can multiply this one by a negative or this one by a negative. Let me just multiply the bottom one by a negative. Okay, negative 1. So my new equation is going to be negative 2/5 y minus 1/5 x equals negative 11, right? So I distribute this negative 1 to each one of these terms, right? And then this one also. Okay, and that makes every sign basically the opposite to what it was. And then my top equation remains the same, except I'm going to just switch these two out. Okay, that way my 2/5 y is right underneath my negative 2/5 y. Okay, 5x equals 14. Okay, so these terms will cancel out, right? Okay, leaving me with a brand new equation of 4/5 minus 1/5 x leaves me with 3/5 x, right? Let me do that work for you so you can see that just in case you missed that. Minus 1/5, right? I have a common denominator, and then 4 minus 1 is 3, right? 3/5 x. Okay, equals 14 minus 11 is 3. All right, so I'm almost done. Let's see here. I want to get rid of this 3/5, so I will multiply by the reciprocal. Okay, and then I got to do that to the same. I got to do the same thing to this to the other side, leaving me with a new equation of x equals 3 times 5 is 15 over 3, or 5. So there's my first variable is 5 for x. Now I can plug it into any one of these equations. I'll just plug it into this one. Here I have 1/5, and then times x is 5 plus 2/5 y equals 11. All right, so let's work this out. So 1/5 times 5, that's basically 1 plus 2/5 y equals 11. Okay, so I need to get rid of this 1 here. Interesting. Oh, that's not 1. That's, sorry. There we go. That's much better. Okay, so my new equation I'm going to do over here, 2/5 y equals 10. So I'll multiply by my reciprocal to get a 1. So I end up with, on one side I end up with a y equals 5 times 10 is 50 over 2. So my y is 25. So there is my answer right here. It is x5, y 25. Okay, so if I were to plug this term, this coordinate point, into each of these equations, I would find that that I in fact do have the answer to these equations. In fact, let me just go ahead and do that just for good measure, just so you can see that. Okay, and I know we've done that for a few of these, but let's do. Never hurts to check. You got to read what the problem is asking. Let's see. Let me go to number 31 real quick. On page 390. It says solve the linear systems using elimination. Okay, that's pretty much what I did. Now, if the instructions also said and check your work, then I would then need to plug this coordinate point into each of these. So let me go ahead and do that. Let's pretend that it did say that. So let's see here, 2/5 times my y is times 25 plus 1/5 times my x, which is 5, should equal 11. All right, so let's test that out. So 25 times 2 is 50 over 5. And then 5 over 5, okay, what does that equal? 50 over 5 is 10, plus 5 over 5 is 1. Does that equal 11? Yes, it does. So that checks out. So this one does check. Let's check out this top one now. Use a different color. So we have 4/5 times x, which is 5, plus 2/5 times y, which is 25, should equal 14. All right, let's test this out. So 4/5 is 4 times 5 is 20 over 5, plus 2 times 25 is 50 over 5. So 20 over 5 is 4, plus 50 over 5 is 10. Does that equal 14? Yes, it does. So both of these check out. So this coordinate point is in fact the solution to both of these equations. Okay, so I want you to keep in mind as we close this section. So far, we've discussed 3 techniques in finding the coordinate point that 2 systems of equations have in common. This coordinate point, again, is the point at which these systems intersect, right? So if that's one line and this is the other, this is what we're looking for right there, what they have in common. And so far, we've used 3 techniques. The first one we used was graphing. If you graph it, you can get a visual and you can actually see where it intersects. And then the second one was by substitution. Okay, you substitute the value of one variable into the other equation, and then there you can find the value of each variable. Go back to video for 6.2 for this one. And then what we just did today, we can either add or we can subtract. Okay, we can subtract equations from each other to find the value of x and y. All right, so this one was for this is video 6.1, this one was video 6.2, and then this one is this one that we just covered in this video. So All right, so having that in mind now and what our overall goal has been and how we've achieved that goal by using these three techniques, let's move on to the next technique in 6.4.